Alright guys, today we're going to go ahead and do section 1.7, which is on finding the inverse of a function. And I know that the microphone is not great on the recording device that I'm using, and I promise I am investigating getting a microphone, so hopefully when we get to chapter 2 things will get much better. So if you can just bear with me for the next couple of videos, I promise I will make improvements each chapter as we go. It's a learning curve for me as well. Alright, so today we're going to talk about what an inverse function is. Okay, an inverse function is going to have that little -1 exponent there. Okay, and that's the inverse of f of x. And what we're going to learn today is how to tell if things are inverse and then how to write an inverse function. Okay, so to tell if functions are inverses of each other, so if we want to tell that f of x and g of x are inverses, what you're going to do is you're going to find f of g of x and show that that's equal to x. In other words, when you do all your simplification, you get x. And when you do g of f of x, you also get x. Okay, and that's going to take us right into our first example. So show that the two functions are inverses. Show these are inverse functions. So you have f of x is 4x minus 7, and g of x is x plus 7 over 4. So what you're going to do is first you're going to find f of g of x, which is what we did yesterday. That's that composition of functions. So if you remember, you're going to take function g and put it into function f anywhere there's an x. So see, there's an x right here, so I go ahead and make my parentheses, and I'm going to bring this guy right in here. So I'm going to put it as x plus 7 over 4. And now I'm going to go ahead and work to simplify and show you that hopefully this is going to be x. So if I multiply 4 by a fourth, they cancel out, and I get x plus 7 minus 7, which is x. Alright, so that works. Now what we want to do is find g of f of x. So I want to take function g, and where I have this x, I'm going to plug in function f. Alright, and now I'm going to go ahead and clean it up. So I get 4x minus 7 plus 7 is 4x over 4, which is x. So since they both evaluated down to x, then they are inverse functions. Okay, and that's how you would show it. Alright, so example 1 done. Alright, so let's talk about the 4 steps to finding an inverse function. Okay, so here I gave you both and said, prove to me they're inverse functions. Now I'm going to give you a function and you're going to give me his inverse. Okay, so steps to writing the inverse of a function. Alright, step 1. Replace f of x with y. And I'm going to go through the steps here. You're just going to write them down, and then I'll walk you through an example with it. Step 2. Interchange x and y. Step 3. Solve for y. step 4, replace y with f negative 1 of x. And I'm going to go ahead and zoom out just a little bit on my note so that we can keep our steps as we work our first problem. Okay? So hopefully you can still see everything good. Alrighty. So example 2. Find the inverse. Alright, so we'll start off nice and easy. F of x is equal to 2x plus 7. Alright, step 1. Replace f of x with y. So y is equal to 2x plus 7. Alright, step 1, easy schmeezy. Step 2, interchange x and y. So I'm going to take the x, okay, the x moved to here, the y moved to where the x is. So did it swaps places. Now, step 3 is where all the work is. Solve for y. Okay, so you want to get y all by himself. If you guys want to flip your equation, you certainly can. Alrighty, so I need to move that 7 over. So I get x minus 7 equals 2y, and then I divide everything by 2. And I get x minus 7 over 2 is equal to y. And then the last step, replace y with f negative 1 of x. And at this point, I'm just going to go ahead and rewrite it using the symmetric property. And that would be my answer. Alright, don't panic if you're still shaky. We're going to walk through 2 more before that I expect you to be able to handle this stuff on your own. Alrighty, and I'm going to go ahead and ignore, I'm going to zoom back in so that you can see a little bit more clearly, and we'll try number 2. I have f of x is equal to 4x cubed minus y. Alright, let's go through the steps. Step 1. Replace f of x with y. Step 2. Change x and y. So he becomes x. And now you're going to go ahead and solve for y. So we have to isolate the y term. So the 1 is going to be the first thing to move. I'm going to divide both sides by 4. Now, how am I going to get rid of this to the 3rd power? What would I do? You're correct. I'm going to go ahead and take a cubic root of this side and a cubic root of that side. So now I have that the cubic root of x plus 1 over 4 is equal to y. Make sure in your cubic root that the 4 is underneath the cubic root. And so now I just clean it up. Alright. So far so good, hopefully. Alright, let's try one more. Let's say f of x is equal to 3 divided by x minus 1. Alright, so step 1 and step 2 should be no problem. So I have y is equal to 3 over x minus 1. Now interchange them. X equals 3 over y minus 1. Okay, don't let it bother you that the y is in the denominator. Still okay. Let's get rid of this minus 1 that's been subtracted from y first. So I have x plus 1 equals 3 over y. Okay, a couple of options here, and they're all going to lead us the same path. We need to get y by itself. This is going to be a little convoluted of a way. So here I'm going to go ahead and multiply by y on both sides. Or if you prefer, we can put a little 1 here and then cross multiply. Alright, but I'm going to go ahead and multiply here by y and multiply here by y. So these go away. And I have y times x plus 1 is equal to 3. So it looks like I have made an absolute mess. But in reality, I've made it a little bit better. I need to still get y by itself, so I need to get rid of this that's attached to y. And remember, this is attached by multiplication, so to undo multiplication, I will divide. So they are gone, and I get y is equal to 3 over x plus 1. And now lastly, just go ahead and replace f negative 1 of x is equal to 3 over x plus 1. Okay? Alright, so the next thing we want to talk about is, if we were to graph the function from the start, could we tell if it had an inverse function? Okay? A function f has an inverse if a horizontal line touches f of x only once. Okay, keyword here is horizontal. Okay, so up until now we've done vertical, and vertical told us whether it was a function or not. So now we're going to utilize the same type of test, but with a horizontal line. Alrighty? So let's see what that's going to look like. This example should be much easier for you. Alright? Determine, sorry about that, if each function has an inverse. Alrighty, so what I want you to do is utilize this time a horizontal line and tell if the horizontal line touches the graph just once. So on number 1, can you see that my horizontal line would touch in these two places? So this does not have an inverse function. Okay, let's try this one. So my horizontal line, as I go up, 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 it's only touching this particular curve once. So this has an inverse function. So I want you to look at number 3. Utilize this horizontal line test and see what you think. And I'm hoping you said yes. So let's try to do maybe one more example and then we'll call it a night. The graph of the inverse function is the reflection of the function about the line y equals x. So if you think back to geometry, these are why we did those reflections about the line y is equal to x. So in other words, if a comma b lies on f of x, then we reverse them. B comma a would lie on f negative 1 of x. Alright, last example. Draw the graph of the function and its inverse. Alright, so my first function, negative 3, 0, negative 1, 2, 5, 3. Okay. Alright, so that function looks like okay, so my new function is going to be a reflection over the line y is equal to x, which is a diagonal line right here. So essentially what you're going to do is flip your point. So this becomes 0, negative 3. This becomes 2, negative 1. And this becomes 3, 5. Alright, so let's graph those. 0, negative 3, 2, negative 1, 3, 5. So it looks like that. And if you envision this diagonal line that cuts across here, do you see that that point, when reflected over the diagonal line, would go here? And this point would go here. And this point would go here. Okay? So that's what it means. Alrighty? So you guys have a great night. Don't forget your practice problems, and I'll see you tomorrow.